300 Earths inside it. And yet, it's made mostly of gas? A planet where storms rage for centuries, lightning flashes are 1,000 times more powerful than ours, and a giant red hurricane larger than our entire world never stops spinning. This isn't science fiction. It's Jupiter, the true king of our solar system. It doesn't just orbit the sun, it shapes the destinies of other planets, pulling comets off course and protecting Earth from cosmic destruction. Beneath its swirling clouds lies mystery, crushing pressure, metallic hydrogen oceans, and maybe a hidden core unlike anything we've ever seen. So what secrets does this colossal world still keep from us? Let's dive into the planet that rules them all. Jupiter, a giant among planets. Jupiter sits as the fifth planet from the Sun, positioned just beyond the asteroid belt, with Saturn as its outer neighbor. It orbits at a distance of about 5.2 astronomical units, roughly 778 million kilometers from the Sun. To complete one full journey around the Sun, Jupiter takes around 12 Earth years. Despite being a gas giant, Jupiter has an axial tilt of only about 3 degrees. This means it experiences virtually no seasonal changes, unlike Earth with its 23.5-degree tilt that gives summer and winter. And because it spins so rapidly, Jupiter bulges noticeably at its equator, appearing wider around the middle than from pole to pole, a characteristic it shares with Saturn. The heavyweight champion Jupiter is the largest planet in the solar system by far. It contains more than double the mass of every other planet combined. Imagine lining up Mercury, Venus, Earth, Mars, Saturn, Uranus, and Neptune, and still falling short of Jupiter's mass. To put it in perspective, Jupiter has about 1/10,000th the mass of the Sun. If it were possible to stand on Jupiter, which it isn't due to the lack of a solid surface, the gravity felt would be about 2.5 times stronger than Earth's. A 70-kilogram person would feel like 175 kilograms. Jupiter's mass creates a fascinating phenomenon. The barycenter, the center of mass between Jupiter and the Sun, actually sits just above the Sun's surface. This means that technically the Sun and Jupiter orbit around a common point in space, rather than Jupiter simply orbiting the Sun. It is the only planet massive enough to create this effect. The solar system's bodyguard. Jupiter's immense gravitational pull doesn't just affect the Sun, it shapes the entire architecture of the solar system. This giant acts like a cosmic shepherd, capable of tearing apart asteroids and comets, or flinging them into entirely different orbits. It has captured over 95 known moons into its gravitational embrace, creating a miniature solar system of its own. Scientists believe Jupiter's presence likely prevented additional planets from forming in certain regions of the early solar system. Over billions of years, it may even alter Mercury's orbit through complex gravitational interactions. Most importantly, Jupiter often acts as a cosmic vacuum cleaner, protecting Earth and the other inner planets by capturing or ejecting many dangerous long-period comets before they can threaten the inner solar system. However, in some cases, its gravity can also redirect objects inward, making it both a protector and, occasionally, a trigger of impacts. Infrared observations have captured scars from massive impacts on Jupiter's cloud tops, objects large enough that, had they hit Earth instead, the consequences would have been catastrophic. A beacon in the night, despite being 5 times farther from the Sun than Earth, Jupiter blazes in the night sky with a magnitude of -2.94, making it the third brightest celestial object visible after the Moon and Venus. It is so bright it can even cast faint shadows under the right conditions. This brightness makes Jupiter a favorite target for amateur astronomers. Even modest backyard telescopes can reveal its distinctive cloud bands and the famous Great Red Spot, offering a glimpse into another world's weather system. Storms and stripes. Jupiter's atmosphere presents one of the most dynamic and colorful displays in the solar system. The visible cloud layer extends about 50 kilometers thick and consists primarily of ammonia crystals. Those beautiful bands of color come from chemical compounds called chromophores, which rise from deeper atmospheric layers and are chemically altered by sunlight and ultraviolet radiation. While the colors and widths of these bands can shift over time, Their latitudes stay remarkably consistent, a testament to the stable yet turbulent nature of Jupiter's atmosphere. And then there is the Great Red Spot, perhaps the most famous storm in the solar system. This anticyclonic tempest is larger than Earth itself and has been observed since at least the 1600s, making it several centuries old. Scientists debate whether it is a permanent atmospheric feature or a long-lived storm, but one thing is certain: it has been shrinking over recent decades. The spot's distinctive red color likely comes from complex compounds processed by ultraviolet light, though the exact mechanism remains a mystery. It sits higher in the atmosphere than surrounding clouds, allowing more interaction with sunlight. Jupiter even has other long-lasting storms, like Red Spot Jr., which formed between 1998 and 2000 when three smaller storms merged together. What's inside a gas giant? Jupiter's composition shows that it is essentially a scaled-down version of the Sun that never ignited. It is made of roughly 90% hydrogen and 10% helium, with trace amounts of methane, ammonia, water vapor, and other compounds. Descending from the cloud tops, the structure changes dramatically. First come layers of gaseous hydrogen. Deeper down, rising pressure turns hydrogen into a liquid. Go farther, and the pressure becomes so intense that hydrogen takes on a metallic form, acting like a liquid metal that can conduct electricity. At the center, scientists believe there may be a rocky or icy core, although the extreme conditions make it difficult to know its exact state. The speed demon Jupiter completes one full rotation in approximately 10 hours, making it the fastest spinning planet in the solar system. However, because Jupiter is not a solid body, different latitudes rotate at slightly different speeds. The poles rotate a few minutes slower than the equator, creating differential rotation that contributes to the planet's complex atmospheric dynamics. This rapid rotation also causes Jupiter's pronounced equatorial bulge. Centrifugal force literally pushes material outward at the planet's middle. Almost a star. Given that Jupiter is mostly hydrogen, a common question arises. Why isn't it a star? The answer is mass. To ignite hydrogen fusion, the process that powers stars, Jupiter would need to be about 75 times more massive than it currently is. It is a giant among planets, yet still a lightweight compared to even the smallest stars. Rings, magnetism, and radiation. Jupiter has four faint ring systems that most people are unaware of. There is one main thin, bright ring about 6,500 kilometers wide, plus wider but extremely faint outer rings composed of dust particles ejected from some of Jupiter's smaller moons. Even more impressive is Jupiter's magnetic field, the strongest of any planet in the solar system, roughly 14 times more powerful than Earth's, and second only to the Sun's active regions. This field creates spectacular auroras at Jupiter's poles and encloses the four largest moons, offering some protection from solar wind. However, the magnetic field also generates intense radiation belts that pose serious hazards to spacecraft. Io, the innermost of the large moons, receives a lethal radiation dose of around 3,600 rem per day, enough to kill a human in hours. A family of moons. Jupiter hosts a remarkable family of at least 95 confirmed moons as of 2024, though most are small, irregular captured objects. The true standouts are the four Galilean moons, Io, Europa, Ganymede, and Callisto, discovered by Galileo Galilei in 1610. These moons are among the largest in the solar system, with Ganymede claiming the title of the largest moon of all, even surpassing the planet Mercury in diameter. Why Jupiter matters. Jupiter is far more than just a beautiful sight in the night sky. It is a gravitational powerhouse that influences the solar system's stability, a natural laboratory for studying atmospheric dynamics, and a key to understanding how planetary systems form and evolve. Its complex structure, powerful magnetic field, diverse family of moons, and ever-changing atmosphere make it one of the most scientifically valuable objects to study. Every mission to Jupiter reveals new mysteries and answers old questions, proving that even in the solar system's own backyard, wonders are still waiting to be discovered. If you enjoyed this journey through the terrifying beauty of space, Make sure to like this video, subscribe to the channel, and turn on the notification bell so you don't miss what's coming next.